Hi, my name is Mr. D, and today I want to take a look at composition of functions. So we have let f of x equal 4x minus x squared and h of x equal 1 over x. And we want to find the value of f of h of 1/2 and h of f of 6. So for these examples, if we start with the first part here, we're looking to evaluate f of h of 1/2. And the way we want to think about functions, especially when we have more than one in this composition example, is we always go from right to left. So one way we could rewrite this, we're going to write this as f of h of 1/2. But notice, if we're going from right to left, 1/2 is being plugged into h first. So if you think about it in terms of machines, we would call this the h machine and this the f machine, and 1/2 is coming down the line here. So we have to plug 1/2 into h first. So we look here, and we have h of 1/2 equals, and now notice for the function h of x, we have 1 over the variable x, but we're replacing x with 1/2 here. So we're just going to write a 1/2 inside the parentheses. But now to simplify, h of 1/2, remember some of you might know this as keep, change, flip, but we're dividing by a fraction, so we have 1. We change this to multiplication, and we flip this to 2 over 1. 2 divided by 1 is 2, 2 times 1 is 2, so h of 1/2 is equal to 2. But what that means is that when we send 1/2 into the h machine, it's going to send out a 2. But remember, we're going from right to left, so we're going to send this number 2 into the function f. So notice here now, when we go to the next line, that we're doing f, but instead of h of 1/2, remember the output was 2. So we're replacing the variable here with 2. So we go to our function f, and notice we have 4 times x minus x squared. So instead of the variable x, we're replacing x with 2 in this case. So we write a 2 in both parentheses, and then we have f of 2 equals 4 times 2 is 8, minus 2 times 2 is 4. So f of 2 is equal to 4. Okay, so for the first example here, our answer is going to be 4. But now for the second example, we want to think about, and notice the output here is 4. But for the second example, things are going to change. Instead of f of h, now we're doing h of f, which tells us, if we use this machine analogy, that we're going to rewrite or relabel these machines. We're going to do f first and then h. Okay, 6 is going to go to f, and then that result is going to go to h. So we rewrite this h of f of 6. We could say that this is h, and in parentheses we have f of 6. So the goal here is we're going to evaluate this at 6. This is going through the f machine first. So the first thing we do need to find is f of 6. So when we simplify, remember the function f is 4 times x minus x squared. So instead of the variable x, we're replacing it with 6. And now when we simplify, f of 6 equals 4 times 6 is 24, minus 6 times 6 is 36. So then f of 6 is equal to 24 minus 36 is negative 12. So this tells us when we send 6 into the machine f, or the function f, it's going to send out a negative 12. So we're sending negative 12 into the function h. That is, we can replace f of 6 now with negative 12. So you're always sending the output into the next function depending on the order it shows up. So then for the next line, we'll get rid of this diagram here. All we need to do now is plug this into h. So we have h of negative 12 equals, and notice we're replacing the variable x. So instead of x, we're going to write blank parentheses, and we're replacing that with negative 12. Just write this a little bit bigger. Okay. So we're replacing x with negative 12. So our final answer here, we could say that h of negative 12 equals, and we'll write this as negative 1 over 12. Okay, well this is going to conclude this video on composition of functions. Thank you all for watching, and I hope that this was helpful.